welcome to the Lab 6 Nuclear Chemistry. Today's lab about the nuclear atoms. I'm going to discuss about the type of the reaction, chemical reactions, chain reactions, and the process and why the nuclear atoms occur. So nuclear bombs are generally made according of the two design. One I think is the gun type method, and another one in implosion designs. So the first one is a gun method. The gun in consider the simplest way and the basic way for the nuclear weapons. So the weapon consists of the tube in which half of the nuclear charge is fixed at one end and the other half is the opposite ends. So and the explosive is placed behind the other half nuclear material. So when the explosive is detonated, the nuclear charge actually race down to the other end of the tube. So once of these halves meet, the chain reactions start and the explosions takes place. So now I'm going to explain about the nuclear fissions. So nuclear fissions involve directing a slow moving neutron at uranium-235 atoms. So the uranium-235 nucleus observe the neutron and become unstable. This results in the fission of uranium-235 into two smaller nuclei. As a result, energy is also released, and 2 to 3 neutrons. So the neutron release cause the chain reactions in the nuclear atoms. So now I'm going to explain how nuclear fission happen in the nuclear atoms. So the fission of the uranium-235 releases 2 or 3 neutrons, which go on to be observed by another uranium-235 nucleus, causing the fissions of this nucleus and the release of 2 or 3 more neutrons, which go into being observed, causing the chain reactions that happen in the nuclear atom. Uranium-235 is naturally occurring uranium isotope used for the atomic bombs and nuclear reactive fuel. For light water nuclear reactors, the uranium-235 is enriched from 0.7 to 3%, and for the bomb grade material is probably over 90%. So making the enriched uranium is actually, the process is very long, very dangerous, and very delicate. So it involves reacting the uranium with the fluorine gas to create the uranium hexafluoride, and then running the uranium hexafluoride gas through a series of high-speed gas centrifuge in a process called gaseous diffusions. So gaseous diffusion is the process to separate different kinds of uraniums. It makes actually the uranium gas move quickly. So the lighter uranium will strike the walls of the chamber more often than the heavier will pass through it. So the one so and for the gas centrifuge is also different, the same thing that separate different kind of uraniums. So the heavier isotope move towards the outside of the cylinder, and the lighter uraniums move to the one that inside, the opposite of the gaseous diffusions. So that's all I have for you today. Thank you for watching, guys.